Hi, welcome back. Throughout this unit, we're going to be talking about quadrilaterals. And in this video, we're going to be focusing on the specific one called a parallelogram. Let's begin. A parallelogram is defined by these specific properties. In general, a parallelogram is a quadrilateral that is composed with a pair of opposite sides that are congruent and parallel. Here's what a picture would look like. Opposite sides would be parallel, while these other opposite sides are also parallel to each other. Now, while the lines are parallel, they will also be congruent. So this will be congruent to this one, and this one will be congruent to this one. So if I were to label this with parallelogram A, B, C, D, I can say that the opposite sides are parallel and congruent. So AD is parallel to BC, and you can also say that AD is congruent to BC. And this is just one pair of lines. We can say the same thing about the top and bottom lines, AB and DC. Another thing that happens when this occurs, when they're parallel and congruent, is that the opposite angles become congruent. So angle D would be then congruent to angle B. So angle D is congruent to angle B. And you can say the same thing about angle A. Angle A is opposite to angle C, and those two are congruent. Angle A is congruent to angle C. Now, as a quadrilateral, the interior angle sum of a quadrilateral will be 360 degrees. Because we can talk about how in our last video, we used the formula n minus 2 times 180 to figure out the interior angle sum of 360 degrees, right? That's the total on the interior side of things. Since the opposite angles are congruent, we can also then say that consecutive angles are supplementary. Consecutive angles are angles that are next to each other. So I can say that angle D and angle A, because they're consecutive, meaning side by side, or not opposite to each other, those two angles are supplementary. Therefore, angle A plus measure of angle D should add up to 180 degrees. And this is going to be true with any two angles that are next to each other. I can say, let's see, measure of angle A plus measure of angle B. Those are equal to 180 because they are side by side. I can say that with B and C. Measure of angle B plus measure of angle C is also equal to 180. And then with C and D. Measure of angle C plus measure of angle D is also 180. So any two angles that are side by side will add up to 180 degrees. Now the last thing that actually also occurs is that along the way we have these diagonal lines. I'm going to draw them in here. Let's draw them in black. These diagonal lines will also intersect at a very particular location. They will bisect each other, which means they're going to cut each other into two equal parts. So notice how I can draw, I'll do this in a different color. This line will be divided into two equal parts. So this piece will be congruent to this piece. And at the same time, I can say that the other line is being bisected as well. So line AC is also going to be cut into two equal parts. So this angle, or this line, is congruent to the other one. Another way to look at this, and we'll talk more about this as we go, is that this point here, we can call it to be the midpoint. This point is known to be the midpoint, we'll put a letter M, of line AC and the midpoint of line BD. So point M is the midpoint. If it's going to cut the orange line in half, it'll be the midpoint of that orange line. And if M is going to be cutting the other line in half, the pink line, we can also say that point M is the midpoint of line AB. So point M would be the midpoint of the two different lines. Now let's do some examples where we apply these different properties into a situation where we can solve for x, solve for an angle, or solve for a length. So here we have the fact that it's a parallelogram. We're going to be given angle D and a length AB and BC. We're going to want to find all of these different lengths. So I'm going to fill in my picture with some information that I know. Since it's a parallelogram, that means that this side is 15 and the bottom is congruent. Opposite sides are congruent. So those two are 15. And at the same time, if BC is 8, the opposite side to it would also be 8. Opposite sides are congruent. So AD equals 8, DC equals 15. Another thing that happens when opposite sides are congruent is that the opposite angles become congruent. So if angle D, and I'll do this in red, if angle D is 68, I can also say that angle B is 68 degrees. I also know that angle A would be congruent to angle C. Now, since the entire quadrilateral on the inside adds up to 360, I can say 360, and I can subtract these two angles that I have right here. I can have 360 divided by minus 68 to find out what's missing, or I can remember that the two angles side by side are supplementary, which means they add up to 180 degrees. So 68 plus something will give me 180 degrees. So 180 minus 68, and that leaves me with 112 degrees. That means that this piece here is 112, which means the angle on the other side is also 112. Any two angles that are consecutive or side by side will add up to 180. So those two can add up to 180, or these two can add up to 180. Or these two, or these two. And at the same time, all those angles add up to 360 degrees. So here I can fill in the blanks with the measure of angle A is 112 degrees, and the measure of angle C is 112 degrees as well. So to recap, opposite sides are congruent, opposite angles are congruent, and angles next to each other add up to 180. So when you're given situations like these, we're going to take the properties that we just learned, right? We want to find the missing measures for the following parallelograms. Here, notice how you're given this length and this length. Since they're opposite of each other, they are going to be congruent for a parallelogram. And congruence really just means equals. 9x minus 25 will equal 5x plus 7. They're congruent. And I can solve for x. I can combine like terms, move the x over, subtract 5x on both sides. 4x minus 25 equals 7. I can move the 25 over by adding 25 on both sides. 4x equals 32. Divide both by 4. X equals 8. On the other side, I'm looking for the length of YZ. I'm trying to find the length. But first, I need to know that opposite sides are congruent in a parallelogram. So I set it up as well. LX, 11x plus 1 must equal to the opposite side. I first need to solve for x, and then I can plug it back in to find the length of YZ. So let's move things around. Subtract 11x on both sides. 1 equals 8x minus 31. Move the 31 over. 32 equals 8x. Divide both by 8. X equals 4. Now, since I'm looking for a length, I want to plug that into YZ. So YZ would equal 19 times x minus 31, or 19 times 4 minus 31. When I simplify, I get YZ equals 19 times 4 minus 31 turns into 76 minus 31. Therefore, YZ, the length itself, is 45. Let's talk about angles. In the previous example, we talked about how opposite lengths are congruent. Here, opposite angles are also congruent. So, if opposite angles are congruent, that means that those two angles are the same. 6x minus 15 will equal 4x plus 11. There's my equation. Solve for x. Move the 4x over by doing the opposite. So you're left with 2x minus 15 equals 11. Isolate the variable by moving the 15 over. 2x equals 26. Divide both sides by 2, and you get x equals 13. Now we're interested in finding the measure of angle B. I want to know what the measure of this is going to be. So if I take my 13 and I plug it in over here, or over here, it doesn't really matter, because they're congruent, right? If I plug it in there, I'm going to end up getting 6 times 13 minus 15. And that gives me 63 degrees. This angle right here for angle A is 63 degrees, which means this side is also 63 degrees. 4 times 13 plus 11 is also 63 degrees. I know that the consecutive angles, these angles side by side, will add up to 180 degrees, right? So angle B plus angle A will equal 180 degrees. Angle B plus 63 should equal 180. So when I subtract 63 on both sides, I can figure out the measure of angle B. Which is 117. Very similar to here, we can figure out the measure of angle R. Now notice how here I am not given opposite angles. Here I'm actually given consecutive angles, which means angles that are side by side. The property here that we use is that angles that are side by side or consecutive are supplementary. So the equation is going to be a little bit different of a setup. While in the previous example, the opposite sides were congruent, I made them equal to each other because they were opposite. But here they're not opposite to each other, they're side by side, which means 3x plus 5 plus 8x minus 12 should equal to 180 degrees total. They're supplementary. And then we just combine like terms and solve for x. 8 plus 3 is 11x. 5 minus 12 is negative 7. Should equal to 180. And as I move things around, I can move the 7 over. 11x equals 187. So when I divide both sides by 11, x equals 187 divided by 11 is 17. Now I'm interested in finding the measure of angle R. Angle R is over here. Angle R is opposite to angle P, which means those two are going to be congruent. So if I can plug in x into angle P, I will automatically find the measure of angle R because those two are the same angle. So angle P is 3x plus 5. So when I plug in the x, I get 3 times 17 plus 5. 3 times 17 is 51. And 51 plus 5 is 56 degrees. That's the measure of angle R. So with angles, we have two different properties. Opposite angles are congruent, and consecutive angles, or angles side by side, add up to 180. And that's how we set up our two different equations. Now, on the last property of parallelograms, parallelograms create diagonals that bisect each other. That's a key word here for this last portion of what we're learning today. They bisect each other, which means DB, this line, will be cut into two equal parts. This will be congruent to this. P is in the middle. P is the midpoint. And at the same time, P is going to be the midpoint of the other line. I'll draw this one in blue. The other diagonal will be cut into two equal parts. This piece will match this piece. So P is the middle of both lines. Now, given that information, let's try to see if we can solve some problems. Here we're given that NS, in our first example, NS equals 2x plus 7. So this piece is 2x plus 7. SQ, the other side of the thing, is 5x minus 23. Since S is in the middle, I can say that those two lengths are equal. Therefore, 2x plus 7 should equal 5x minus 23. And now I can solve for the variable, for missing variable x. Subtract 2x on both sides, because this piece is congruent to this piece. 7 should equal 3x minus 23. When I move the 23 over to the other side, I get 30 equals 3x. Divide both by 3, and I get x equals 10. Now, usually, we're going to want to plug something back in. We want to find the length NQ. NQ is the full distance, the total distance. So, NQ is going to be equal to the first piece plus the second piece. NQ is the total distance combined. So when you plug in a 10, we're going to plug in 10 into this equation, here and here. So we have NQ equals 2 times 10 plus 7 plus 5 times 10 minus 23. And with some basic math, we have NQ equals 2 times 10 is 20, plus 7 plus 5 times 10 is 50, minus 23. We definitely want to multiply first because that's part of PEMDAS, right? Multiplication comes before addition and subtraction. And then you can combine all of these together. 20 plus 7 is 27, plus 50 minus 23. NQ equals 27 plus 50. That's 77 minus 23. And lastly, when you combine them all together, 77 minus 23 is 54. That is the full length of the line NQ. Let's try this next example. If TV is 74, let's label this line. TV from here to here is 74. And WV, which is just this component, I'll do this in red. This is 74. And WV, this piece, is 4x plus 1. Find the value of x. Well, I know W is the midpoint. I know that the length WV and the length TV, these two lengths are going to be congruent. This piece and this piece are the same. So there's several ways to think about this. You can label this other piece on top also 4x plus 1. And the total of the two lines is 74. So one way to set up an equation is to say 4x plus 1 plus 4x plus 1 should equal a total of 74. Or, since you're only given this little piece, WV, you can say 2 times the length that you're given should equal the total, because point W is in the middle, or it's half. So if I double the length, I will also get 74. Either way, you're setting up the same problem. You can combine like terms and solve for x. So let's say here we have 8x plus 2, because I'm combining the like terms. And that equals 74. Notice how over here, if I distribute, I get the same thing, right? 8x plus 2 equals 74. That's why it doesn't really matter which equation you set up, because you can add the same thing to itself, or you can multiply it by 2 to get the total. And since they're the same, I'm just going to solve for one side. Subtract 2 on both sides. 8x equals 72. Divide both sides by 8. And x equals 9. And that's going to be the same thing here. And since this one said solve for x, we're done. So diagonals bisect each other. It cuts the line in half, or into 2 equal parts. So let's say that we have the coordinates here. We have a parallelogram with different points. These last two pieces, or these last two sections of our set of notes, we're going to now try to prove or find the situation that proves everything that we've covered, but on a coordinate grid. First, I'm going to graph these. I'm going to choose a point, something that stands out. 3, 6 is going to be here. This is point A. Point B is 5, 8. 5, 8. This is B. 3, -2. 3, -2 is C. And 1, -4. 1, -4. This is D. When I connect these, it creates a parallelogram, kind of a long parallelogram. I'm interested in figuring out the intersection of the diagonals. Where do the diagonals intersect? So if I were to draw a line from here connecting to the opposite side, B to D, and A to C, where do they intersect? Now my picture doesn't do it justice, so I can't really tell you where it intersects based on the picture, but I do know that the lines are going to cross at the midpoint. So all I really have to do is find the midpoint. And if we think back to our midpoint formula, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. This will allow us to find the midpoint between any 2 points. So pick 2 points. Which 2 points do you want to use? Use points that are opposite of each other. So use point B and point D if you like. B and D. Or you can find the other 2, the midpoint between A and C, because those are opposite to each other. I'm going to label this x1, y1, x2, y2. When I plug it into my formula, the midpoint will be, I add the x values. So x1, x2, 5 plus 1 divided by 2, and the y's as well, y1 plus y2, 5 plus negative 4 divided by 2. As I simplify, the midpoint ends up being 5 plus 1 is 6 divided by 2. 5 plus negative 4 is 1 divided by 2. And as I simplify, 6 divided by 2 is 3, and 1 divided by 2 is 0.5, or 1/2. That point will be at 3 and, let's see, I used the wrong number up here, sorry. Let's trace back my steps. Because notice how 3 comma 1/2 is right here and doesn't look like it intersects there anywhere. But I actually did make a mistake. Sorry about that. In the y's, I didn't have the correct y. For the y's, it was supposed to be 8 plus negative 4, and I did not use 8. Even a math teacher makes mistakes, and even a math teacher can check their work to see if they did it correct. So, 8 plus negative 4 is 4. And 4 divided by 2 is 2. That would make more sense, right? If I'm looking at the intersection, 3 comma 2 is more up here. And that's more in the middle. Now I can draw this line straighter here and here. The point of intersection is the midpoint of any two opposite points. This is the point of intersection. Okay, lastly, we want to determine whether or not the following points create a parallelogram. And there are several ways to check that. First, let's start by plotting the points to make sure that we know what it looks like. So, point A is at negative 7, 4. Negative 7, 4. This is point A. B is at 1, comma 2. C is at 9, negative 8. Let's see, this is going to be B. 9, negative 8 is going to be on the right side, all the way to the bottom. And D is 1, negative 6. 1, negative 6. This is the letter D. When I connect these, I want to figure out whether or not this creates a parallelogram. And there's really 3 things that I want to confirm. Any one of these 3 things will be true. Opposite sides are congruent. I also want to be able to check that opposite sides are parallel. Or I can check that they both share the same midpoint, right? The diagonals will bisect each other. So there's really 3 things that we can do here. Let's talk about this, right? If opposite sides are congruent, what does that mean, opposite sides are congruent? It means that the distance of the lines are the same. So if we want to do that, if we want to check that this distance is equal to this distance, we're going to want to use the distance formula. x2 minus x1. Let me put this here on the side. To check that the lengths are the same, I'm going to use the distance formula. So that's the square root of x2 minus x1 squared plus y2 minus y1 squared. I can use the distance formula to find the lengths and see if this length equals this length and if this length equals this length. So I would have to do the distance formula 4 times. I can also check to see whether or not the opposite sides are parallel. Parallel means that they have the same slope. And I would just have to check that the opposite lines to each other have the same rise over run. So does the rise over run equal on opposite sides? So I would have to check the slope for all the lines and make sure that the slopes opposite of each other, or the lines opposite of each other, are the same slope. And then lastly, if I want to check that the diagonals bisect each other, I'll do this in orange. If they bisect each other, I would find the midpoint between these two, and I would find the midpoint between these two. And if those two lines have the same midpoint, we can say that they bisect each other. Both lines have to have the same point of intersection. So you can use any of these three to check, and you can confirm that this is indeed a parallelogram. Let's check the slope. Opposite sides are parallel. So why don't we check the slope? Let's do this one in red. Let's find the slope or rise over run from A to B. From here, we're going to go up 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So rise over run. I went up 2, and then 8 to the left side over negative 8. So I did 8 to the left. 2 over negative 8 is negative 1/4. Let's check the opposite side. We're going to go down 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 2 over 8, which is also negative 1/4. So far, opposite sides are parallel because they have the same slope. Let's check the other slopes, the other diagonals. If I check these slopes, I'm going to go, the rise over run would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I went to this side, so it's 1, 2, 3, 4, 5, 6, 7, 8. So the rise is, if I'm going to go from A to D, I'm going to go down 10, so negative 10 over 8 to the right. And I can simplify that by dividing both by 2. Negative 5/4 is the slope for this line on the left. Diagonally across from it, BC, let's count the slope here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 1, 2, 3, 4, 5, 6, 7, 8. And the negative direction, which also simplifies the negative 5/4. So notice how these slopes are opposite and they're the same, and these slopes are opposite and they're the same. Opposite sides are parallel. We know that this is a parallelogram because opposite sides are parallel. Now, I can use the distance formula to check the length of their congruent, and I can check that the diagonals bisect each other. Why don't we check this last one in orange? Because technically by checking the slope, if opposite slopes are the same and they all meet in the same direction, they're going to have the same length by default, right? Let's check the diagonals. Let's check the midpoint between B and D. So if I want to find the midpoint of B and D, I'm going to use the x values, B and D. x1 plus x2 divided by 2. So 1 plus 1 divided by 2. And the y values are 2 plus negative 6 divided by 2. So the midpoint of B and D is going to be 2 divided by 2 and negative 4 divided by 2. 2 plus negative 6 is negative 4. When I simplify this, the midpoint here of BD, let's see, the midpoint of BD will be 1, negative 2. I want to find out if that midpoint is the same as the other one, from A to C. So now I'm going to use A and C with the same formula. the midpoint of AC. You add the x's, negative 7 plus 1 divided by 2, and you add the y's, 4 plus negative 6 divided by 2. I'm going to find this midpoint. Negative 7 plus 1 is negative 6. Divided by 2. I added the wrong numbers again. Notice how the x's are negative 7 and positive 9. So this would be a 9. Negative 7 plus 9 should be 2 over 2. And 4 plus negative 6 is negative 2 over 2. It's just not my day. Negative 4 plus negative 8. Right? I add the x's together. Negative 7 plus 9, and then I add the y's. 4 plus negative 8. And that should give me 4 over 2. When I simplify, I should get 2 divided by 2 is 1, and 4 divided by 2, negative 4 divided by 2 is negative 2. Because both lines share the same midpoint, I know that this point here, 1 and negative 2, is the midpoint for both diagonals. And that proves that the diagonals bisect each other. I think that the longest method would be the distance formula, where we would find the distance of all 4 lines, so we can prove that the opposite sides are congruent. And here you go. If we take things back, this is really what we're talking about today. The application of 4 different properties. Opposite lines are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary, which means angles that are next to each other add up to 180, and that the diagonals bisect in the midpoint. This is really the essence of it. I know that as we got towards the end, some of these examples became more complex, but I want us to make sure that we focus on the basics. What is it that we're really doing here? All right, let us know if you have any questions. I hope this has helped. Don't forget to like and subscribe, and as always, we'll calculate.